today we are going to discuss this problem that is 6. And the problem name is minimum operations to make binary palindrome. Okay, so let's read the problem. So we are given an integer array nums, and for each element nums I, you may perform the following operation any number of times, including 0. That means we can increment nums of I by 1 or decrease the nums of I by 1. Okay, and a number is called binary palindrome if its binary representation without leading zeros reads the same forward and backward. Okay, we already know what is binary palindrome, and our task is to return an integer array answer where this array represents the minimum number of required to convert each integer into a binary palindrome. Okay, so let's understand the problem with the help of an example. So what we are given, let's first discuss what we have given an array nums. Okay, like we have an array of 1 to 4, something like this, the array 1 to 4. Okay, and what we have to do is we have to return we have to return an array, okay, that contains like 0 1 1 0 1 1. This is the minimum number of operations to convert each given integer into an binary palindrome. That means we have to take each element from the given array nums and make that number to its nearest palindrome integer, and then return how much we have to make the operations by doing +1 and -1. So this is given an array nums, and we have to take each integer, okay, and we can do only +1 or -1. Then by doing this we have to make that the current integer binary form becomes palindrome. Okay, that means for each integer we can do only +1 or we can do only -1, and by doing this we have to make that integer form becomes palindrome. Like if we talk about the third element, that is 4, and if we talk about the binary of 4, the binary of 4 will be 101, and we can see that the binary of 4 is already a palindrome. That means we don't have to make any +1 in this or -1 in this to make it palindrome. So the required number of operation for this 4 is 0. Okay, so if I talk about something like suppose we have talked about 10. So if I talk about the binary number 10, how we calculate the binary number of any number? We do like this: we first take 1, then 2, then here 3, okay, then 4, then 5. Suppose first 1 2, then 4, then 8, then 16, and for 10 there will be only 8 will contribute and 2 will contribute. That means the binary form of 10 will be 1010, And if we see our first goal to make this binary number into an, what we are here doing first understanding the problem. What we are doing, we are understanding the problem. Okay, so suppose if this is a binary number and it is not in palindrome, we can try adding +1 or doing -1, and we have to get any number whose binary is palindrome, and we have to do this minimum. So we can check if we consider +1, so we can check for what? We can check for 11, 12, 13 dot 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 until we get the binary. And if we consider -1, then we have to check what? As written, we can check 9, 8, 7, something like this. And finally, which closure number will become the binary? We have to return how many times we do +1 or how many times we do -1. I think the problem is clear now. Now it's time to build the solution. It's time to build the solution. So what is the first thing that comes in our mind to see this problem? In my mind, the first thing comes as we can start from a given number like 10, and we will check 1 for 11, then check for 1 minus 9. Then if anyone become palindrome, we will return the number of operations. Then we will go 1 more plus, then 1 more minus, then 1 more plus, then 1 more minus, until we get the number that is the nearest possible palindrome. Okay, so first thing comes in my mind, this I hope you understand. We can check for alternate +1 and -1 and try to get that it is palindrome or not. So what we can do, if I think about the solution, the first approach that comes in my mind is like we can start something while loop, and we can check first +1, make first +1, then check for binary, then check -1, then again check for binary, and when any one become binary, just return number of operations. That's it, and break the loop like that. This is the first approach that basically comes in everyone's mind, I think. But you can see that doing this will be very much time consuming to consider out. Okay, so what can we do something else? To look for something else to get an intuition, we always try to dry run or try to understand the problem with the help of example. So let's play with examples and say what can we see. Okay, what if I can take a number that is 17? Okay, and if I talk about the binary number of 17 will be this 16 and 1, that is 17. The binary of 17 will become 1001. That is already a palindrome. Okay, If I talk about 16, 16 is what? 16 will be 10000. Okay. If I talk about 15, 15 will be this. That is already in palindrome. Okay. So to make 16 palindrome, we can add 1 or subtract 1, both will become an palindrome. Okay, but this is our first idea, and this will be very time consuming for other numbers. It will not always be possible. So we still not get any intuition how to approach for an optimal one. So let us go with 19. 19, okay, 19, 16, 17, 18, 19, that is 10011. Now to make this nearest, to find out the nearest palindrome, that is the binary number, what we can do to find out the nearest one, what we can do, any idea? We can try out +1, that is for 20, then 21, or we can try out for 18, 17. Okay, so if I try out for 20, okay, so for 20 what I will get? For 20 I will get 1. If I talk about for 20, 20 is nothing but 10100, that is still not a palindrome. If I talk about 21, it will be 10101, that is a palindrome. Okay, and if I talk about 18, 18 will be 10010. Okay, now palindrome. 17, 1001, that means it is an palindrome. Okay, so our starting number was 19. Our starting number was 19, and we are getting the closest as 21 and 17. So let me show you that 19 is what? 19 is something like 10011. Okay, and we get nearest palindromes like 17. 17 is what? 10001. Okay, and the 19 was what? 19 was 10011, and we get another nearest same palindrome, that is nearest we can say 10101. So can we build some relations here? Because if we do here in the first approach +1 -1, it will become like very much time consuming. So we have to anyhow build the palindrome in very less, like we just have to build the palindrome with the given number palindrome in view of one time, I think we can say. So in these two I can see something like what? The nearest I can see the pattern is it is -2 and it is +2. Okay, and I can a little bit see like what the similarity in these two numbers is. The first three numbers are same here. First three numbers are same. In 19 and 21 I can see the first two numbers are same. First two numbers are same. Okay, so in the palindrome, this is the odd digit palindrome. So if we do something like this, that is if we ignore the middle one, if we ignore the middle one in the both, okay, ignore the middle one in the board, I can see that it is nothing but the reverse of the first two digits, the nearest palindrome. And in 21 also it is the reverse of the two palindromes, and this and the middle bit is just flipping. Okay, so from this example we can get an idea, like for the given binary palindrome we can, if anyhow, make the half as same and just reverse the first half in the second side. We will get the nearest palindrome. Okay, as you can see in this example, middle one is ignored, and we can say that the nearest will be the first half, and this flip that, and the first half just flip that. So one idea what we get, the idea number one. What? The idea number. What do you get? The idea number one. Idea number one is just flip reverse the first half. Just reverse the first half, and we will get the nearest palindrome. But this it will guarantee that it will always be a nearest palindrome. We can check with the other examples, like what? Other examples can be like that the idea one is here. We are seeing the other idea. Like if we have given as what we can say, what we can take the example 19, we have taken 20. If we take some bigger numbers, like if we go with 30 this time, so 30 can be what? 30 can be 16, 8, that is 24, this 4, 28. Let's not example of 30. Okay. Our previous example was 16. First we have taken 16 months, and the binary of 16 or 1 0 will be 0 1 0 0 0 0. Okay. So as I can see that 17 is the nearest palindrome, but also 15 is the nearest palindrome, I can say, and the 15 is 1 1 1 1. Okay. So in this, can we get this 15 by just reversing the half bits? I don't think so. In the first idea, we get getting the reverse the first half, and we will get the nearest palindrome because we are keeping the most significant bits as the same. That will near about guarantee that we will near about get the nearest palindrome integer. But in this example I can see that just making the, if we just reverse this, then how we get this? So to get this we can do like what? We can do like something like this. If we make the middle one as unchanged and just subtract 1 from the left half, if we subtract 1 from the left one, we only get 1, and make this as same and just reverse this. This will be one possibility. Sorry. How we are going to get this? That is the problem. If you are an odd, delete. So we can, if we try to make As our first idea was to just reverse the horse. If we see a number like the this is a very huge binary number like this. Let me show you 1011 1. Like whenever we saw a number like this, okay, and suppose we have to make this number, as this is not a palindrome, and we have to make this number as a palindrome. The one good idea we can do is we can first subtract 1, then check, then add 1, then subtract 1, as by continuously or doing plus plus 1, checking, or doing minus minus 1 and checking. We can check all integers who will give the nearest one will be our answer, but this will be a time consuming, so we have to think something different. If we are not able to do the plus 1 minus 1, the one thing that is remain is to generate palindrome directly with the given palindrome. So in order to generate the palindrome, suppose this number is given and we have to generate the nearest possible palindrome, binary palindrome. In order to do so, if we have to generate, what we can do, in palindrome the half is same as the first half, and the second half is same if the number is even, and if the number is odd, except the middle one, the first half and the second half is same. So if we have to generate with the given number, we can do like we can take the first half and just copy paste that first half into the second half, and we will get our one palindrome we can get from the given number. Okay, this can be nearest. Okay, but there is something like when there are some numbers in which the number of digits got reduced. Suppose there is the 10000, and the nearest palindrome can be one digit length and all ones. Okay, so suppose we have taken this half as 1, and we are just copying pasting into the second half. This will be one possible way, and the second possible way is we can do a plus 1 in this number and then copy paste in the second half. And the third thing we can do, that we can just do a minus 1 in the first half and just make the copy paste in the second half. That means in the 3-way we can generate 3 palindromes, and it will guarantee that in the 3 generated palindrome 1 will be the nearest, because we are not doing anything with the most significant bits. And to handle some edge cases, we are doing plus 1 minus 1 as well as in the first half, and just copying pasting then the second half. So these three methods will the 3 methods will guarantee that one will be the nearest palindrome. I hope the idea is clear. So what we have to do, we have to take the first half, just one time copy paste the first half, then the other time first make plus 1, then paste in the second half, then and the third time do a minus 1, then copy paste in the second half, and we will find one of them as the nearest palindrome. So this is the whole idea that we can do. So if I talk about the code, how we can code for this. Okay, so we have to extract the first half, and we have to return a vector of the answer. Okay, and let me take the size as this array, and at the end we have to return for each element in the array, so we can traverse in each element in the array, and we can generate the palindrome for all the elements in the array. Okay, so the num_i is our first element, so we have to generate the palindrome. So we have to take the first half first. Okay, but it, the first half will depend on the what the first half will depend on the even and odd numbers in the binary number. So we have to first make the number into the binary. Okay, so let me take the binary number. There will be we can make some function that convert into the binary and pass this in the current integer into the function. And now we have the binary number. We have to take the first half. Okay, but if the number is odd and even, we have to make the different situations. Okay, so if the number is odd, that is our current num_i is odd. This is for what? That is the number is odd, so we have to take the first half, the string, the first half. What can be the first half? The first half will be the take the binary and take a substr, start from 0 and take the whole size, that is n/2, not n/2. Let me make the size that is something like integer size, that is the binary dot size, and to take the first half we can do a n/2. Now we have the first half string. Okay, so as the number is an odd number, something like this, 10010, this will be the first 5 numbers, then there will be another number, and in the other there can be any number, something like this. This, if we consider this example, this can be said as 5, 5, 10, 111. This is an odd number binary. So we just have to extract the first half. We already extracted above, and we have to make the copy paste this side. So we have to make the first, we have to reverse this first half. Okay, so to reverse the first half, we can make another string, that is something like a reverse string, something like the reversed. It first will be the same as half, then we will call our reverse function. It will reverse the number. Now we have reversed the number. Now with the first string we can do is just copy paste here. What we can do? Okay, wait. In the middle, either we have a 0, we have a 1. So we can generate 2 strings, either by taking in the middle 0 by ourselves, either by taking 1. So the first possible way, the first possible string we can generate, that is a that will be a palindrome. It will be the first half, then we can take a 0 for odd, and this reversed. And the second we can generate first with taking half, then a 1, then a reversed 1. So we have got the 2 numbers another. Now this will near about guarantee that in both of them the one will be the nearest palindrome. But for some edge cases we can try adding 1 and then reverse, and try adding -1 then reversing the number. Okay, so we have to make more, we have to generate more palindromes. So we have got our first and second string, possible generator substring. Now what we do, we take the first half and make a +1. Okay, now this time +1 in second half, first half. So how to do +1? We can something like make a required number variable, and there will be a function we can make further that is convert into the number. Take this half and make it as a number. Okay, now take this required number, we can do a plus plus. Now we have the +1 in our current half. Now we can again make a string something like what, something we can store in our half. What we can store in our half, this current required number, make this into the binary, this current number. Now we have our third generator substring that will be this half 1 times 0, but we need first reversed. In order to get the reverse, we can first store in our reversed what. We can store the first half and make it as the reverse dot begin reverse dot end. Okay, now this will be our reversed third string, and fourth can be take the half, add the 1 and make it as reversed. Now this time we will do -1 in the half. So we have our required number that is 1 more than the current number. So to get the 1 -1 in the first half, we can do here required number, go with -2. Now this is the -1 from the current. Okay, we can again take the half and convert it into the binary, this required number, and take a reversed as this half, and again reverse this reversed X string, reversed dot end. Now we have our fifth string, fifth possible string that can be what? Nearest palindrome. This is a string. Okay, this is our sixth. 1 plus reversed. Now you can see that if the number is odd, we can possibly have 6 string possible that can be the nearest palindrome, that is nearest candidate palindrome. Okay, so the first, by taking the current and adding 0 1 in the middle, then we can do +1 in the first half and add 0 1 in the middle, and adding -1 in the first half, and we can have this 2 more possible substitute. Now what if the number is even? Now here we do not have the in the middle 0 or 1. That means in this we only have 3 possible substrings. Okay, 3 possible substrings. So for that, this will be required. This we can just copy paste from here and just paste it out here. That with half will be this, reverse will be this. We have to reverse and just remove this first 0 items. Okay, and this one, and this is an even. Now we have 2 strings. Now we can do a +1 and -1 to form, in order to form the +1 and then -1. Now no need for the second one. Okay, there will be first. So for this we can take the required number, make a ++, make it reverse, and just do this. So for the other one, we have this required number, we don't need this stuff, and just name it out as second possible substring. And for the third, in the -1, we can copy this much, and we have something like this. Just we have to remove the 0, and this will be our third. Okay, So as we are here, we have a 6 in the first, in which the length is odd. We have this, that is 6 possible substrings, so we have to take the minimum one. Okay, so we can take the minimum as the min of what? We have to count the operations, and the operations will be the absolute nums of I minus first, and then absolute nums of I minus second. We have to copy this 6 times, so we can take a copy of this. What happened? Take a copy. 3, 4. What happening? We have 3. Copy. Page 4, 5, 6. Okay. First, second. We can go with third. Then we can go with fourth. Then we can go with fifth. And then we have sixth. Now this much we have a minimum, and we can push in our answer this minimum one. Okay, and in this, and in the even situation, we can have the min and the minimum of, and the minimum of what? Absolute nums of I minus first, absolute nums of I minus second, absolute nums of minus third. I hope you are able to understand that why I am doing the nums of I minus first. Well, we have to count the number of operations we have done, plus 1 and minus 1, so we just need to subtract from that. Okay, but wait. This first, second, third is a string when we have to convert them all into the binary first, and that means in the integer first. In the integer, so there is one more column that is still left. We can make a function like C, and this we can make a function that is converting to the number. This is the function, and this will you have to paste. Okay, this is, let me do it for all. So I have added this absolute values. Okay, so I have added this convert number function into all these. Okay, at the last we have to take this minimum into the our answer array. Now there is two more thing that will just still remain, that is we have to make the function convert binary and convert number. So we are going to make the first convert into the binary. It will take an number. So how to convert a number into binary? We can simply, if the number is 0, this is the edge case, we can just simply return an 0. Okay. Now, if it's not the possible, we can take an answer and the input is string. And while the number is greater than 0, we simply push in our answer the number modulo 2 and add the +1 to make it as character. At the end, we can make our number and divide by 2, and we can then make the reverse this answer. Okay, and just return this what answer variable. Now this is how we can make our binary converter. Now this time to make a number converter. Okay, we are getting a string. So how to make this string into a number? We can just simply make a number, we can answer as 0, and we can start reversing from the string right, that is the size -1. until the first character in the current element. We should have something like a power variable that is starting with 0, or we can start this with 1 and that multiply by 2 at each step. I think so. Yes. So in our answer we have to add what? Because we have to take our current element and subtract with 0. Now we get our number. Now in the number we have to multiply with our power. Okay, get the number, multiply with my power and update the power by multiplying by 2, and at the end just return the answer. I think everything is fine. Now we can test by running the code. Let's test it out. There is some error, non-void function is not. Okay, so I will not return the answer array. Okay, it fails on the test case. That is something like this, and the answer 3 is come out to be 1. For 6, the output is come out to be 3. We have done some silly mistakes anyway. Let me check it out. When we are checking the odd and even length, so we are taking the nums up. It should be the size. Now let me test this. It passes. Let me try to submit it. Oh, it's a sparse. I hope everything is clear to it, and let's meet in another video. Thank you so much.